Hello, in this video we're going to use the K-map one more time to find the minimum sum of product, but this time we have the don't care condition. This don't care condition means either you could use it as a 1 or a 0 as long as it will help us minimize the Boolean expression. So let's start first by building up this table. So as we know, we have x1, x2, x3, x4. So we use basically 1, 1, 1, 0, 0, 0, 0, 1, meaning this is negation here and here. The same here, 1, 1, 1, 0, 0, 0, 0, 1. So as we see here, you have a 1 here. So if we highlight this one here, this is 1, 1, 1, 0. So we have, here is 1, 1, and 1, 0. So we have this one here. And the next one is this one, which is 0, 1, 1, 0. Right here, we have another one, 0, 1, 0, 0. The last one, 0, 0, 1, 1. And the don't care, we have 1, 1, 0, 0. And we have 1, 0, 1, 0. And the last one is 0, 0, 0, 1. So it looks like this one, if we keep it as a 0, it will be better. But if this one here is a 1, it will help a lot. So this don't care here, we're gonna make it a 1 so we could have this group. And you consider don't care as a 1, which means we have x1 is gone, so we're gonna leave x2 and then x4 not. So this group here is x2, x4 not. So apparently this one, if it is a 1, we're gonna have a bigger group. We're gonna have this, and therefore this will be, if you look up, is x1 not, x2 not, but to the side, x3 is gone because it deviates from a 1 to 0, and then we have just x4. So the minimum sum of product become for this function is x2, x4 not plus x1 not, x2 not, x4. And now we're going to see an example of the Quine-McCluskey procedure, which is the second method of reduction. So we organize information from the canonical sum of product form into a table to simplify the search for terms differing by only one factor. So the procedure is 2 steps process, paralleling the use of a K-map. First, find the grouping of terms, just as we looped together marked square in the K-map, and then eliminate redundant grouping and make choices for terms that can belong to several groups. So here is an example. In this example, we have the truth function is shown below. The 8 4 tuples of zeros and ones producing a function value of 1 are listed in the table below, which is separated into 4 grouping according to the number of ones. So what we do, we're gonna group everything that has a 1. Anything with a 1, I'm gonna highlight. So what we're gonna do is that we're gonna group them right here with how many numbers of ones do they have. So these are the ones that we care about. So we're going to place them here, how many numbers of ones. So we start, how many of them has 3 ones. So let's see how many of them have 3 ones. So this first one has 3 ones. So which is 1, 0, 1, 1. And then we go, how many of them have 2 ones. That's how the Quine-McCluskey procedure works. For this example, I choose 4 inputs, x1 to x4, but this procedure works when you have 100 inputs. So what do? You let the program, you program it and let the computer do this comparison and so on. So 2 ones, let's see, I have 0, 1, 1, 0, and I have 0, 1, 0, 1, and then I have 0, 0, 1, 1. So I'm grouping with the 2s. So how about only 1, 1? I have this one, 1 0 0 0, 1 0 0 0 here, and then I have 0 0 1 0, and then we have 0 0 0 1, and the last one is none, no ones at all, which is this last one. So right here I copy down all the ones, but I group them, how many ones they have, either 3 ones. I don't have 4 ones, so if I had all 4 ones, I would start with 4 or 2, 4, 3, 2, 1, and none. And here is what I would do. First, I'm going to write it in decimal. What is this in decimal? What is 1, 0, 1, 1? This helped me track it better. So 1, 0, 1, 1 in decimal is 11. It's a decimal number. I put a box around it, and so on. So I could do the rest. So here we convert binary to decimal, and now the procedure starts. This is just collecting all information. So the procedure is that I compare one group against the one next to it. I never compare 3 with the 2. I compare 3 with the 2. I never compare 3 with the 1. I will compare 3 with 2, 2 against 1, and 1 against none. Because what I'm looking for, only one deviation from 0 to 1. So if I look at this group, 1 0 1 1 with 0 1 1 0, I have change here, I have change here, I have change here. 3 changes, no good. I go next, 1 0 1 1, compare it with 0 1 0 1. So how many changes from 1 to 0? I have 1 and 2. Now good, so I continue. So if I go 11 against 3, and I'm talking decimals because it's easy to say, 11 against 3, I have 1 1 1 1 0 0, and then 1 0. So I have one deviation in sign. So right here I'm gonna write, choosing 11 and 3, we end up with a dash. That means there is a change of sign from a 1 to the 0, but everything else stays the same. 0 1 1 0 1 1. And now I have become only 2 ones. And then I'll do the same. I'm done with comparing the 3 with the 2. Then I compare a 2 with the 1. So you have 3 versus 3. That means 3 times 3. I have 9 comparisons to do. So 6 and 8, as you see, 0. One deviation, another deviation, another, no. It's too much. So again, I compare 6 with the 2, and I compare 6 with the 1. I don't see only one change, I see more than one change. Then I go 5 with the 8, 5, and then 8. So as you see, 1 0, one change, 0 0, another change, 1 0. So more than one change. But 5 and 1 is okay. 5 and 2, more than one change. So I'll go 5 and 1. Let me copy down. This is very important. So if you look at that, I get 0 dash 0 1. And I continue. I see that 3 and 2 will give me 0 0 1. Don't care, or dash. That means there is a change. Also 6 and 2. So if you compare 6, which is 0 1 1 0, with the 2, 0 0 1 0. So I see that this one changes, it becomes 0 dash 1 0. And then 3 1, which is 0 0 dash 1. Now we're done comparing the 2 and 1, and we minimize it to just 1 1 1. So all of this group here has 1 1. Now we go compare 1 with none. So that's an easy comparison. So you have 8 and 0, that will be dash at the first one here. X1 will become a dash. And then 0 0 0. Make sure you copy down the decimal. This is gonna help us a lot later, this decimal tracking. And then I see like a 2 and a 0. Give me 0 0 dash 0. And then 1 and a 0. It'll give me 0 0 0 dash. Then this become a none. Then you do this procedure again. You're going to compare the 2 with the 1. But here we have to match the dashes. So 2 with the 1, there is nothing we could do because the dashes don't match. You have to compare. The dashes must match, and you must have only one deviation from the 0 to 1. So obviously nothing works here because we have all zeros here and you have dash here. So the 2 with the 1, numbers of ones, doesn't work. Let's compare the 1 with the none. So first I have to match the dash. So here I'm changing my color just so you see. This dash here doesn't happen in the other ones. But I see like this dash and this one here, they match. And then from this one and a 0 become a dash. So if I do another table, so what we did here is we compare first the dashes. So like this dash here, there is nothing to compare it with. So we move to this dash with this one here. And so this one deviate to 0, so become a dash. So we end up with 0, 0, dash, dash, and comes from 3 to 0. And the next one where we have is 3, 1, 1, 0. So again, this group 3, 1, 2, 0. So, and we end up with 0, 0, dash, dash. So as you see, they are very similar. They're the same, basically, not only similar, they're the same. And because they come from the same source, 3, 1, 2, 0. So the next step, second step that we said in minimization is to group everything in this table. So the first thing you do, write down every decimal you started with. All these ones here, they are right here in decimal. So I'm writing them down right here. 11, 6, 5, 3, 8, 2, 1, 0. So, and then I'm going to write it in binary as well. And here is what I end up with. Did I use all of them? Did I use 11? This one will stay. So these 2 here that we already get minimized to this one here, we're not going to use. Like this. All of this get minimized to this one here, which is 0, 0, dash, dash. Okay? But what's left? What's left is this one here, which is dash 0, 1, 1. So we have dash 0, 1, 1. We use it. Comes from 11 and 3. Comes from 11 and 3. The next one is 0 dash 0, 1. And it came from 5 and 1. I crossed this by mistake. I meant to cross this one here. And we have 0 dash 1, 0 comes from 6 and 2. So I use this. And then dash 0, 0, 0 come from 8 and 0. And the other 2, the 4 of them, this 3, 2, 3, 1, they get minimized to this last one, which is 0, 0, dash, dash. And as you see, they came from 3, 1, 2, and 0. And then I stop and think, did I use all of these? Yes, I use all of them. Nothing left. And now this is the most important part. So this is the most important part right here. First, we're going to look for the prime implicant. Prime implicant, I mean, I look for the column that has only one marking, one X. The columns that have only one marking. So this one is by itself within the column, and this one, and this one, and this one. And that's about it. Those are what we call prime implicant. So what we do is we find the prime implicant, this one here. We're gonna cross horizontally and cross vertically. So these prime ones are essential. They are very important. So they cover up the others. So we cross horizontally and vertically. So we cross horizontal and vertical. This one is prime, cross, horizontal and vertical. This one too. And this one too. And what's left? are very essential. The other ones, like this one here, it was redundant. It was already covered. So it's redundant. So you find the one that by itself in the column, and you cross horizontally and vertically, and if they get anything in their way get crossed, it's not important, it's redundant. And so what we have left with? What we are left with is this one here, which is x2 naught, x3, x4. And then the next one here, this is essential, and this is basically x1 naught, x3 naught, and x4, because you don't copy down the don't care, we don't write it, plus x1 naught, x3, and x4 naught, plus the last essential one is this one, which is x2 naught, x3 naught, x4 naught. And this is how we find the minimum sum of products using Quine-McCluskey procedure. So again, all the ones, you're gonna group them, or how many ones they have. You're gonna write down this decimal, just help us better, see it better. And so you copy them down, you compare and look for one deviation from 1 to 0, and regroup them and keep going. And make sure you use all of them. If I didn't use one of them, if I didn't use 11, for example, I must write 1, 0, 1, 1 right here in my last table, because that's an essential, it's never been used. Okay, so you could do the K-map to see how it works. If I'm gonna match with this same minimum sum of product. So we go 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1. And if you put everything in a table from the function itself, you get 1 here, 1 here, and these 2. And then if you group this, we either can group it as all of this is 1, group of 4, and then we could have a group of 2, like this. So as you see, this one here, this green one, so this group of 4, we don't need it because it's covered. Everything is covered. So I don't need this one here. So if I group it this way, so this become, you have deviation from 1 to 0, so it's gone, or you could make it a dash if you want. And then you have 0, 1, 1. And right here, if you look up, I'll change my color. So if you look up, this 0 and 1 changes, but so you have a 0 dash 1 0. And right here now, this 1 1 0, what changes is that first one, 1 0. So you have a dash 0 0 0. That's what we have here. And the last one, we have changes from 0 to 1, so you get 0 dash 0 1, 0 1 right here. So if you look at this group here and this last group here, they are the same, which is basically this x2 naught, x3, x4, and remember this is x1, x2, x3, x4. So if you have a dash, you don't write it down. So what do you have? x2 naught, x3, x4, x1 naught, x3, x4, and so on. This the same minimum sum of product. So right here, what I was talking about verbally is all written here. I would recommend you read it and go over this one, or try a different example and match. See, use the Quine-McCluskey procedure and use the K-map until you become familiar, until you get the same answer with it. And then usually you could program it and let the computer do all the comparison, and it will just give you the result when you have 100 inputs, for example. I hope this video is helpful.